Hey folks, how's it going? Mr. Mitchell here. In this video we're going to go over question 4 from the 2016 SQA Advanced Higher Physics exam paper, so let's get into it. Question 4 says Epsilon Eridani is a star 9.94 times 10 to the 16 metres from Earth. It has a diameter of 1.02 times 10 to the 9 metres. The apparent brightness of Epsilon Eridani is measured on Earth to be 1.05 times 10 to the minus 9 watts per metre squared. Part A says to calculate the luminosity of Epsilon Eridani. And there's 3 marks available here. Well, writing down what we know from the question, we're trying to find the luminosity L. We know the apparent brightness B is 1.05 times 10 to the minus 9 watts per metre squared. And we know the distance D is 9.94 times 10 to the 16 metres. So writing down our equation relating luminosity, apparent brightness and distance, we have B equals L over 4 pi D squared. Substituting in the numbers gives 1.05 times 10 to the minus 9 is equal to L over 4 pi times 9.94 times 10 to the 16 squared. And then to get L on its own, we can multiply the 1.05 times 10 to the minus 9 by this denominator here. And if you do that in your calculator, remembering to square root this term, you should get an answer for luminosity of L equals 1.30 times 10 to the 26 watts. Part B says to calculate the surface temperature of Epsilon Eridani, and again there's 3 marks available here. Well, writing down what we know from the question, this time we're trying to find the surface temperature T. We know that the luminosity L is 1.30 times 10 to the 26 watts that we just calculated. The radius R can be found from dividing the diameter by 2, which will give us 5.10 times 10 to the 8 metres. And lastly, Stefan Boltzmann's constant sigma is equal to 5.67 times 10 to the minus 8 watts per metre squared per Kelvin to the minus 4, and you'll find that value in the datasheet. So writing down our equation relating luminosity, surface temperature, radius and Stefan Boltzmann's constant gives us L equals 4 pi r squared sigma t to the 4. Substituting in the numbers gives 1.30 times 10 to the 26 equals 4 pi times 5.10 times 10 to the 8 squared times 5.67 times 10 to the minus 8 times t to the power of 4. Well, in your calculator you can do the left hand side divided by this term here, and that will leave you t to the power of 4 on its own, and then you need to take the 4th root of that answer to find t on its own. So doing that in your calculator should give you an answer of t equals 5150 Kelvin. Lastly, part C says to state an assumption made in your calculation in part B, and there's 1 mark available here. Well, you could state any one from the following assumptions here. You could say that the star is a black body, you could say the star is spherical or has a constant radius, you could say the surface temperature of the star is constant or uniform, or lastly you could say no energy is absorbed between the star and Earth. That's all for this video folks, thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a like, subscribe to the channel, and I'll see you in the next one. Take care.